Okay, now let's see how do we use complex conjugate to do the division. Uh, we all know that what is the division? The quotient ratio, a over b. In a real case, a over b is equivalent to the multiplication a with 1 over b. So if we know how to compute 1 over b, we know the division, right? So now let's see how do we get the reciprocal of a complex number. Okay, so reciprocal z is a plus bi. We want to compute 1 over z. Okay, 1 over z. Okay, let's start. 1 over z. Well, 1 over z, we do the following trick. We're going to multiply top and bottom by the complex conjugate of z. If z is not 0, whenever you have reciprocal, of course, z is not equal to 0. For whatever number, the 0 cannot be the denominator. So when z is not 0, z bar is not equal to 0. Okay, z is not equal to 0, then z bar is not equal to 0. So we can multiply top and the bottom by z bar. Okay, and what is z times z bar? In the last video, we computed z times z bar is a squared plus b squared. So the denominator becomes a squared plus b squared. What is z bar? Z bar, remember, z is a plus b. Z bar is a minus bi. Z is a plus bi. Z bar is a minus bi. So now you're at the position a minus bi over a squared plus b squared. What it means? It means a complex number times a real number. 1 over a squared plus b squared is a real number. This is a multiplication. We know how to do this multiplication. Okay, so it's just first term times this, a times it, minus b times 1 over a squared plus b squared is b over a squared plus b squared, and times I. And this is the reciprocal. The reciprocal. Reciprocal. This number. It looks very complex. But anyway, well, let's see what we can have. Let's try it. If z is 3 plus 4i, find the reciprocal of z. Well, let's try it. Reciprocal 1 over z. 1 over z is 1 over 3 plus 4i. We multiply top and bottom by its conjugate. Its conjugate is 3 minus 4i. 3 plus 4i times 3 minus 4i. And the denominator is a squared plus b squared. So a squared is 9, b squared is 16. So it's 3 minus 4i over, this is 25. So it's 3 over 25 minus 4 over 25 times I. And this is a reciprocal. Well, reciprocal, what is the meaning of the reciprocal? The product of this number with itself, with the original number, is equal to 1. Let's try it. Let's verify it. Let's verify, see if it is equal to 1. So 3 times this number. So it's 9, 3 times 3 is 9 over 25. 3 times this number minus 12 over 25i, this times it, plus 4 times 3 is 12 over 25 times I. 4i minus 4i times 4 over 25i. These two terms cancelled. I squared is negative 1, negative sign, and this negative 1, negative sign, they cancelled. 4 times 4 is 16. I say cancelled it, plus 4 times 4 is 16, 16 over 25. Well, 9 over 25 plus 16 over 25 is 9 plus 16, 25 over 25 is equal to 1. See? We just check what we're looking for, or what we find is exactly the reciprocal. Reciprocal just means the product is equal to 1. Okay? So, very cool. So again, this process depends on the fact that after multiplying top and bottom by the reciprocal, after multiplying top and bottom by the conjugate of the denominator, we make the denominator a real number. When we have a real number, this is the reciprocal of a real number, it's still a real number. It's like a real number times a complex number. It just means real part times real number. Complex part, imaginary part times a real number. Right? So this is the reciprocal of a complex number in the standard form. This is in the standard form. You get it? So it's a little bit complex than the real numbers. Okay, so after you know how to find the reciprocal of a complex number, now let's see the division or the quotient. Okay, so first 1 plus 4i 5 minus 12i. So how do we do this? We're going to do this almost the same thing. Here, the crucial step is that you multiply top and bottom by the complex conjugate of the denominator, and then you turn the denominator a real number. Here we do exactly the same thing. We're going to multiply top and bottom by the complex conjugate of the denominator. 5 minus 12i, its complex conjugate is 5 plus 12i. See, nothing changes, right? You just multiply top and bottom by the same number. They can be cancelled. You still get the original number. And then for the denominator, you have a complex number. Multiply with its conjugate, then it is equal to 5 squared plus 12 squared. This is denominator, a squared plus b squared. And numerator, see, if you cover the denominator, numerator is just product of two complex numbers. You do term by term. 1 times 5, 5. 1 times 12i, 12i. 4i times 5, 20i. 4i times 12i. 4i times 12i. I squared is negative 1, so minus 48. It's a product. Minus 48. Okay, and then let's check 5 minus 48, negative 43. 12i plus 20i, 32i. Over 25 plus 12 squared. 12 squared is 144. 25 is 100. Add 25, 169. So in the standard form, it's negative 43 over 169 plus 32 over 169i. This is your answer. Okay, so the crucial step, the initial starting step is the multiplication of top and bottom by the conjugate of the denominator. Be careful, it's a denominator. Okay, there's no second way to do it. This is the only way to do the division. Okay, for the second problem, second example, again we follow the strategy we have. So we multiply top and bottom by the conjugate of the denominator. Conjugate of the denominator. Okay, here's minus 3i, it becomes plus 3i. And then this becomes 4 square plus, plus 3 square. A square plus b square, it's always a square plus b square. It's a sum of two positive numbers. And for the numerator, you're going to do the term-by-term multiplication. 2 times 4, 8. 2 times 3i, 6i. Minus 3i times 4 minus 12i. Minus 3i times 3i minus 3i times 3i. This is negative 1 cancelled, so it's plus 9. So what we get, 8 plus 9, 17. 6i minus 12i minus 6i. What's this? 25. So it's a 17 over 25 minus 6 over 25i. See it? So the arithmetic computation, addition, subtraction, multiplication, division, are all discussed. Addition, subtraction are very simple. Real minus real, imaginary minus imaginary. Multiplication, just term-by-term multiplication, and don't forget I squared is equal to negative 1. Division is slightly complex. To have division, we need the complex conjugate. To get the complex conjugate, and then we multiply top and bottom, always multiply top and bottom by the complex conjugate of the denominator, always the denominator. And after that, the numerator is the product of two complex numbers. And then you just be careful about the calculation, write down the final answer in the standard form. Whenever you try to write a complex number, so far you always write like a plus or minus bi, a number plus or minus another number times I. But be careful, a in this example in the standard form, a is this 17 over 25, b is negative 6 over 25. A and b both contain signs. Don't forget the sign. If there's no sign, it's positive. But don't forget the b part. B part of this b is a negative 6 over 25. Okay? So now let's do more exercise. If z is 2 minus 3i and the w is 5 plus 2i. Okay. Write each of the following expressions in standard form. Okay, we're going to write in the standard form, means like this. Okay, a z over w quotient. So it's a 2 minus 3i over 5 plus 2i. How do we do the quotient? We multiply top and bottom by the complex conjugate of the bottom. So here the bottom is 5 plus 2i, so you multiply it by 5 minus 2i. Okay, it's very rigid, no second way. And then the denominator is always a squared, b squared, a squared 25, b squared 4, 25 plus 4. Numerator, 2 times 5, 10, 2 times 2i minus 4i. Negative 3i times 5 minus 15i. And this is minus 6. So it's a negative. Negative, negative. They're cancelled. I squared will give you the third negative sign. 3 times 2 is 6. Okay, so 10 minus 6, 4. Minus 4i minus 15 and minus 19i over 29. So it is 4 over 29. This one is not a standard form. Again, this is not standard form. If the question asks you to write in standard form, you must write as two parts, a plus bi. This one is the answer. This is not the final answer. This is not the final answer, okay? Okay, that's our quotient. Second one, we compute the conjugate of the sum. Conjugate of the sum. So z is a 2 minus 3i. W, 5 plus 2i. After we finish the addition, we put the conjugation. Okay, so 2 plus 5, 7. Negative 3i plus 2i is minus I. Conjugation. Conjugation just changes the sign in front of I. So it's a 7 plus I. 7 plus I. This is the standard form. Part C, z plus z bar. Z, what is z? Z is a 2 minus 3i. Z bar is 2 plus 3i. Okay, 2 minus 3i plus 2 plus 3i. If here is a plus sign, you don't have to. You can omit the parenthesis. If it's a minus sign, you must keep the parenthesis. Okay, 2 plus 2 is a 4. Negative 3i, positive 3i is 0. Cancel. So this is the answer. Okay, so the answer is number 4. Okay, so from this answer, we can see that if z is a plus bi, then z plus z bar is always twice of the real part. Why? Because imaginary part one has one sign, the other one has the other sign, so they always cancel. So you only leave real part there, and so that's why it's doubled. Right? That's why it's doubled. And the other observation is the following. If you have z equal to a real number plus 0i, then what is conjugate? Conjugate is it's a minus 0. Minus 0i is still a. So for a real number, this is a real number, meaning of the real number. For the real number, its conjugate is itself. The conjugate of a real number is the real number itself. The conjugation of a real number does not change the output. Okay? So one observation. And second observation, z, a plus bi. Z bar, a minus bi. Well, if you consider this as a complex number, what is the conjugate of this number? The bar of the bar. You're going to change this to b plus again. But a plus bi is z. So it's like the switch. You have on, off. You switch it twice, you're back to the original position, original state. Okay, so let's see, theorem. we always have z double bar equal to z. Conjugate of the conjugate is itself. The conjugate of the conjugate of a complex number is itself. Okay? And second, if you have z and w, and you add them and take the conjugate, it is equal to first, you take the conjugate, and second, you take the sum. Okay? And three, you have two complex number, you do product. After you get the result, you compute conjugate. It's equal to you take the conjugate first and then put the product. Okay, so they are the just plain computation. Just go, for example, z is a plus bi, w c plus di, and you compute z plus w and then conjugate, and you compute z bar plus w bar and check what they are, and then eventually you will see they equal to each other. Eventually they equal to each other. Okay, just compute the left hand side, compute the right hand side. For example, I'm going to do this one. So z plus w bar is equal to a plus bi plus c plus di, and then closure, not closure, the conjugate, and a plus c, and b plus d, conjugate, and this is the I term. You take the conjugate, you change the sign, minus b plus d I. This is a one side, the left side, the right side, z bar plus w bar is z bar a minus bi, w bar c minus di. It's addition, so you don't have to copy the parentheses. And then you're going to add real part, add imaginary part, and you see, so because they are both equal to this expression, so you get z plus w bar is equal to z bar plus w bar, and that's it. So you, at the beginning, you cannot set, okay, they equal to each other, and then you get step by step. You must start from one side, get the other side. All right? And you can try to use this to prove the difference and the product, and also actually the quotient. All right, that's a arithmetic of complex numbers. Complex number, the most important or mysterious part is I. What is the property of I? I squared is equal to -1. I squared is equal to -1. Well, square, double, product with itself. If you do not have product, I is I. If you have a square, it's -1. What is I cubed? I cubed, by definition, it's a squared times I. A squared is -1, so it's -1 times I, it's -I. Then I24, what is I24? I24 is I squared times I squared, right? This is 2 copies, this is 2 copies, the sum is 4 copies. And this is -1 times -1. The product of -1 is +1. So you take 4th power, you're back to 1. All right? And then what is the 5th power? 5th power is 4th power with additional power. But 4th power is 1, so it's I. So 5th power is back to the 1st power. And 6th power is 4th power and I squared. 4th power is 1, so you just get I squared. I squared is -1. Okay? And you can continue. You will see that the I to 7th power is equal to I cubed, because I to 4th power is equal to 1. So what we get? We get a pattern. What is the pattern? I is I to first power, fifths, 9, 13, 17, and so on. How do I get those sequence? This sequence, you see, first is okay. Fifth power, and between first and the fifth power, there are 4. The difference is 4. So every 4 copies of I, you will get a positive 1. Okay, so that's why 5 plus 4 is 9. I to 9th power is also equal to I, because I to 9th power is I to 4, I to 4, and I. This is 1, this is 1, so it's just I. So every 4 numbers, you will get an I. And similarly, negative 1 is I squared, every 4. I to 6, I to 10, I to 14, I to 18. You just add 4. 14 plus 4 is 18. And the negative I is I cubed, I7, I11, I15, I19, 1. I to 4, 8, 12, I to 16, I to 20. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and you can continue. There is a periodic property. The periodic property is written this way. The powers of I repeat with fourth power, every fourth power, every fourth power. After every four times, you will repeat. Okay, so this is a special property. You may not see what the usage of it, but we will have some example which will give you the strong hint to apply this property. So for example, evaluate 8 powers of I. For example, I to 27. Well, I to 27, remember how we get I to 9. We just separate 4, I to 4, I to 4, I to 1. I to 27, you also have I to 4, I to 4, I to 4. How many times? 4 times 6. 4 times 6, 24. So you will have I cubed. I to 4 and then to 6 power. 4 times 6, 24, plus 3, 27. And I to 4 is 1. 1 to 6 power is still 1. So it's I cubed. I cubed is negative I. I cubed is negative I. This is 1. Right? And B, well, this year is 2021. Let's try 2021. We need fourth power. So I to 4. Let's try 505. 505 times 4 is 2020. So we miss 1 copy. This is a 1. So 1 to 505th power is still 1 times I. So this is I. Okay, so you just isolate copies of 4 copies of I, and that is 1. You get another 4 copies of I, it is 1. So eventually you drop almost all the numbers except either I or I squared or I cubed or 1. Okay. One more example will finish this lecture. Write 2 plus I cubed in the standard form. First one, this has a formula, x plus a cubed third power is x cubed plus 3x squared a plus 3xa squared plus a cubed. So the power of x is 3, 2, 1, nothing. Power of a is nothing, 1, 2, 3. The coefficient is 1, 3, 3, 1. That's a way to memorize this product formula. Well, this formula is required. It has a twin formula. If you have x minus a cubed, you will have almost same formula, but it becomes minus, plus, and minus. Okay, they are the twin formulas. You're supposed to know them. You will use them in the pre-calculus and the calculus. Okay, back to the problem. 2 plus I cubed is 2 cubed, 8, plus 3 times 2 squared, 4 times I, plus 3 times 2 times I squared, and plus I cubed. Okay, 8, here is plus 12I. I squared is negative 1, so minus 6. I cubed is negative I minus I. Okay, so 8 minus 6, 2. 12I minus I, 11I. This is the answer in the standard form. Okay, this is the answer in the standard form. Okay, so far in this section, we introduce the complex number to solve the equation x squared equal to negative 1. And that is called imaginary unit. And we write the complex number as a plus bi. And then we try to study the addition, subtraction, multiplication, division of such type of numbers. We want the answer in the so-called standard form, a plus bi form. And then we also discover the pattern behind the powers of I. Every fourth power, the powers of I will repeat. And this property will help us to simplify some high power of I. Okay? Okay, so we finish this lecture and we will continue the discussion in the next lecture. Okay, thank you very much.